Welcome back. Next, I'd like to introduce a design pattern that's commonly used with recursion, called helper method recursion. So far, all the recursive functions we've written are single standalone functions like factorial. It is recursive itself. We call factorial from outside the function, and factorial itself calls factorial inside its own code. That's been the case with all the functions we've written so far. With helper method recursion, it's a little bit different. So this code doesn't actually do anything. This is sort of just a pattern that I'm laying out. But with helper method recursion, we have two functions. We have the outer function here, and then inside we have our recursive function. So this recursive function calls itself, as you can see here. Again, this is just the pattern. I'm going to show you a concrete example that does something in just a moment. But that's why it's called helper function or helper method recursion. We have our main outer function that we would call, like as a developer from outside here, we would call outer and pass something in. And then inside the code of outer, there's another function defined, and it calls itself recursively. So this is commonly done when we need to compile something like an array or a list of data. We're not simply tabulating, we're not multiplying one value over and over and over like we were with factorial or summing different, summing range. That was another one we did. If we're doing something like this, collecting all the odd values in an array, it's very easy to do helper method recursion. We create an empty array where we will then store our data in, and then we call our helper function. So the reason we do this, if I just try to define a function called collect odds, which accepts a list of nums, if I tried to make a variable called result, and I set it to be an empty array, this is where we're going to put the odd numbers. Well, if we're doing a recursive function, no matter what I put after this, every time it's called, result will be reset to be an empty array. So how are we going to collect our data? How are we going to have, this piece that persists throughout? And one easy solution is to define result outside of collect odds, like this, and then add to result in here. And rather than having result float around in the middle of nowhere like this, we use helper method recursion, which really just means defining a function around it. So here's my solution, or a solution to this problem. Oops, looks like I'm missing a bracket. Update that slide. Oh, there it is. Okay, zoomed in too much. So what we have here is collect odd values, which is what we would actually call down here. We'll pass in let's do a simple one. Something like this. And it takes that array in. It makes our result array that's empty. Then here's our recursive logic. And ignoring that for just a moment, we call the helper function, which we defined here, with the array. And then we return result that was defined up here. So this is going to manipulate result. It will be adding to result. And again, the reason we do this is that if we tried to define result inside of here, it would be reset to an empty array every time through. So with helper method recursion, we can get around that. And this is a common pattern when we are trying to compile some sort of result, usually an array or some other sort of data structure along those lines. So the actual logic here, if we do want to walk through this, if we look at helper, it's executed at the bottom with array. So this is array, this is passed in, and we have a base case where if the helper input is empty, if the length is 0, we just return. Otherwise, we check if the first input or the first element, mod 2, is not equal to 0. That means that it's odd. So if it's not divisible by 2 cleanly, it's odd. So we push helper input 0 into result. Then the next thing that we do is call helper, but this time we call it on everything else in the array, excluding that first element. So we make a subarray like this, a smaller array, and we pass that in to helper, and we run it again. And it's not empty, so we don't return. And then we take the first element, which is this, and we check if it's even or odd. Well, it's even this time, so this doesn't run. So then we call helper again, helper input.slice1. So this time, instead of this subarray, we look at this one. So we're always looking at the first element, and we're shrinking that array, and shrinking it until it's empty, and we return. Okay? So that's the logic behind it. But this pattern, whether it's odd values or we're doing something else, so later in the course, this is a flash forward. Do not worry about understanding any of this, but this is from the graph section of the course. We define a method called depth first recursive, which has a result variable. And this actually is, it's an example of helper method recursion. Here is the helper method defined inside of our other function. And we call it down here, and it's updating the result variable. Anyway, we'll come back to this, not the focus. I just wanted to show you that this is a real thing. I'm not just making it up or showing it to you for no reason. This is an actual traversal of a graph data structure, something a little more complex. Okay, so this is one way of doing the solution, but this is not the only way of writing collect odd values recursively. You can do it without a helper function. You can do it without having to define result outside in a different scope and then updating result. It's just that this is simplistic. It's easier to understand. In the next video, I'm going to show you how to do this the pure recursion way, which is not necessarily better. It's a little more confusing, but it is all recursion. There is no helper method. It's a little shorter, but we'll get there. That's coming up next. So helper method recursion is just a pattern where we have an outer function that's not recursive, which calls an inner function, which is recursive. Okay, I'll be quiet.